Hi, my name is Paul Melchin, and I'm presenting work by myself, Asudeh, and Dan Siddiqui on a Ojibwe Agreement in lexical realizational functional grammar. This is part of a project where we're developing a theoretical framework that combines features of lexical functional grammar with the approach to word formation in distributive morphology, or DM. So the resulting framework we refer to as lexical realizational functional grammar, or LRFG. It's intended to be particularly well suited to modeling languages that exhibit polysynthesis and non-configurationality, such as those found in Canadian Indigenous languages. And so in this talk, we summarize the framework and demonstrate it with an analysis of a subset of the Ojibwe inflectional system. So LRFG is similar in most ways to standard LFG, and the changes mainly involve the C structure and its relationship with the words and morphemes. The F structures and S structures are going to be more or less familiar to those from standard LFG. But in the C structure, the terminal nodes aren't words themselves, but instead they're abstract. They're F descriptions, so sets of F structure equations and constraints. And then this is mapped to a separate structure, a V structure or a vocabulary structure, which is a linearized structure in which the vocabulary items, or VIs, expone or realize the features in the terminal nodes via a correspondence function, V. And so formally, the V structure is a list, each member of that list being a feature structure with 4 attributes. So there's the phonology attribute, which basically serves as the input to the phonological system. So it's a list of phonological elements or bundles of distinctive features or whatever. And there's the dependence feature. And in the dependence feature, itself contains 2 features. So there's the crisis feature and the align feature. So the crisis feature basically encodes whether the VI is phonologically or prosodically dependent on an element to its right or left. So basically whether it's an enclitic or a proclitic. And then the align feature has values that capture whether, with respect to this, it's the host on which it's phonologically dependent, whether it occurs as a suffix or as a prefix. And so canonically, an element that is a proclitic, so dependent on something to its right, is going to have the aligned feature L, meaning that it attaches as a prefix on that element. Or something that is an enclitic will have the aligned feature R, meaning that it aligns as a suffix on the element to its left. This preserves the order of terminal nodes in the C structure with respect to the elements of the V structure. But defining these features separately allows us to account for very local mismatches in order. So for instance, it allows us to account for the Latin conjunction que, which is phonologically dependent on an element to its right, but then it appears as a suffix on that element. So que can be looked at as a suffixal proclitic, whereas Romance object clitics can be thought of as being phonologically dependent on something to their left, but appearing as a prefix on those elements. So they can be thought of as a prefixal enclitic. And so this allows us to account for very local mismatches in order between the C structure and the V structure, but aside from that, the order is going to be preserved between these 2 structures, between the terminal nodes of the C structure and the elements in the V structure. And so this is captured by the equations in 2 and 3, the constraints there. And so in terms of the correspondence architecture, the V structure can be thought of as preceding the phonological string. So it maps to the phonological string through this function O. And in terms of the V structure and the C structure, the relationship between terminal nodes and vocabulary items can be many to one. So in the kind of typical case, it's going to be 1-to-1, but this many-to-one relationship allows us to use the mechanism of spanning, wherein one VI can realize features of multiple terminal nodes. So the resulting model is very similar to the lexical sharing model of Westcote in various ways, but it maintains the complex internal structures of words as part of syntax. So in other words, Westcote's theory allows for multiple C structure nodes to map to a single item, but in the lexical sharing analysis, that single item is itself an unanalyzed thing. So it's created in the lexicon, and it's kind of itself not divided into multiple pieces, whereas our model allows us to kind of maintain the complex internal structures of words as a part of the syntax. And so it'll account for the fact that long words very often have internal structures that mirror the order of elements in the syntax. And so in this paper, we simplify things a little bit because we don't have these mismatches in order caused by the Clysis and align features. And so we're treating the output of the exponents function just simply as a string, not as the full VI structure. So a string written in standard Ojibwe orthography and indicating whether it's a prefix or a suffix just by having the notational convention of a dash to the left or the right of the string. Now I'll very quickly go over the exponents function v. And so this maps from a pair of elements to a vi, the exponents of the arguments. And so the first argument of the exponents function is a list of pre-terminal categories, so noun, verb, and so on. And very typically the list will have a length of 1. So this will be when you have a one-to-one mapping between terminal nodes and VIs. But when you have a VI that spans multiple terminal nodes, the list will have more than one element, which will be taken in the linear order that they occur in the tree. And the second argument of this function is itself a function phi, which maps the F description, which should match the F descriptions in the C structure nodes, to a set of F structures that map that satisfy that description. And so V maps from a pair whose first argument is a list of C structure pre-terminal node categories, and whose second argument is a set of F structures to a structured expression, the VI itself. And there's certain conditions on exponents that ensure that the right VIs get exponed or realized with respect to the certain terminal nodes in the C structure. We have it written out formally here in 5 and in the discussion below that, and we invite you to take a close look at that and kind of give us feedback on whether we seem to have it right. Basically what it amounts to is a combination of what in DM is referred to as the elsewhere condition or the subset principle, meaning that the VI that is inserted is the one that is the best match for whose features match most closely the expressions in the C structure node, and an economy constraint which enforces spanning whenever possible. So if you have a V structure where fewer VIs expone the same number of features, then that V structure is preferred over one where you have the same features exponed by a greater number of VIs. So basically, when you can have spanning, then you should. And so that kind of brings us to the end of the exposition of the theory itself, and now we'll look at our analysis, kind of putting the theory and the framework into action by looking at Ojibwe inflection. So Ojibwe exhibits many of the features that we hope to be able to model very well, including non-configurationality, polysynthesis, and a direct inverse-based agreement system which cross-references all the core arguments in a clause. And so Ojibwe has various features which are relevant to our analysis here, which I won't get into very closely here. There's grammatical animacy, which is a system of grammatical gender, which often matches the notional or semantic animacy, but not always. There's a system of obviation where third-person animate clausemates will be kind of contrasted by whether they're proximate or obviative. So generally speaking, the more kind of topical or the more discourse prominent third-person argument is going to be treated as proximate, and anything else is going to be treated as obviative, so kind of more backgrounded. And this is marked morphologically on nouns and on verbs in verb agreement. So animacy and obviation, together with person, play into what is referred to often as a prominence hierarchy, which determines a few things in the language. So it determines which VIs will get inserted for certain agreement slots, and also determines direct and inverse marking. So prominence hierarchy can be listed as in 6. The unspecified actor plays into the prominence hierarchy, but we won't get into it here. Basically, participants, so first or second person arguments, are ranked above third person arguments. And typically the second person is seen as ranking above first person, but that kind of depends on there's certain VIs for which the first person appears to be ranked above the second person. And we account for that in our templates, which we'll get to shortly. And among third-person arguments, animate arguments are ranked above inanimate arguments, and among animate arguments, proximate arguments are ranked above obviative arguments. And so this prominence hierarchy plays into the direct and inverse marking, where basically in a transitive clause, the relationship between two arguments' relative ranking in the prominence hierarchy and their thematic roles, the more agent-like and more patient-like argument, is tracked by the direct and inverse morpheme, which is known as a theme sign, and which we analyze as voice. So basically, when the agent is the more prominent argument and the patient is the less prominent argument, the verb is marked as direct. And when the patient is higher ranked and the agent is lower ranked, it's marked as inverse. And we analyze this as shown in number 8. So we discuss a few different ways of looking at this in the Algonquian literature, but we adopt what we call the grammatical functions as prominence analysis. So basically, for the most part, we assume, and we formalize this with a constraint that we'll get to later on, we assume that the higher ranked argument in the prominence hierarchy is always a subject, and the lower ranked one of the prominence hierarchy is always the object. And so this can be kind of was formalized, as we'll show later on, but basically this means that what direct and inverse marking show is the mapping between the grammatical function and the theta role. So as a mapping, it's part of the mapping from the F structure to the S structure. And so in the kind of canonical case, the higher ranked one element, which is the subject, is going to be mapped to the agent of the first argument 1 in the Finley argument, or the Finley mapping theory that we adopt here. And the lower ranked one, the object, in a clause marked as direct, is going to be the patient. This is marked with the solid lines here, whereas the dashed lines here indicate inverse marking, where the subject maps to the patient and the object maps to the agent. And so this allows us to treat direct and inverse marking as part of the mapping between F structural objects, the grammatical functions, and these S structural objects, these thematic argument roles. It also allows for a more kind of intuitive way of mapping the C structural positions of the subject and object, as well as the specifications of various VIs. And so, again, in section 4.3, we formalize this analysis. And before getting to the analysis itself, I'll just point out that this is not an exposition of the entire Ojibwe Agreement system. It only accounts for clauses where all arguments are animate, and for the agreement morphemes that are found in declarative clauses in matrix clauses. And so in subordinate clauses or in non-declarative clauses, you have a separate morphological system, which we don't discuss here. And so in order to discuss our analysis, first I'll give you an example of some of the C structures, F structures, and V structures for a representative example, which shows most of the things that we're going to be incorporating here. And this analysis involves the LFG mechanism of templates, where a template called like this, @inclusive, is actually standing in for potentially quite a bit longer F description. So here, this @inclusive tells us about the breakdown of the person features. So basically, this shown here, whereas the plural template basically says that ups num equals plural. And so we have an example structure in here. So this is the structure for a sentence that translates as "they saw us" inclusive. So this demonstrates a few things. So first of all, because first person inclusive is ranked higher than third person, this means that the subject here is actually going to be the patient, us, and the object is going to be the agent, they. And so this is marked by invoking the inverse template on the voice head, and we'll talk about these templates a little bit later on. And so this C structure here is basically drawing from kind of contemporary analyses of Ojibwe, like syntactic analyses of Ojibwe, mostly in the minimalist literature. So basically, you have the verb root, which contains the pred feature C. What is called traditionally by Algonquianists the verb final, which indicates the verb class, this meaning that it's a transitive verb with an animate object. There's a voice head, which tells you whether it's direct or inverse, or things like reflexive marking, and so on. The agar head here has features of both the subject and the object. So it has the person features, the number features, and the pred equals pro features. So we're assuming the pronominal argument hypothesis. So this tells us that the subject is first person inclusive and that it's plural, and that the object is a third person proximate plural argument. And then you also have these two clitic nodes where the CLO node indicates features of third-person plural objects, and the CLS indicates features usually of the subject, but only person features. And here is the same thing, but with the kind of templates exploded to show the actual features that are encoded in these templates. So the templates that we use allow us to encode various things, including so there's two main groups. There's the ones that encode agreement features, so person and gender and number, which allows us to encode the prominence hierarchy. And then there's other ones that encode verb class and lexical mapping, so whether it's direct or inverse. And so first I'll talk about the agreement templates. And so for these, we're basing this on an idea that has kind of been standard in analyses of Algonquian languages, at least since Beher and Rezat's 2009, which basically is the claim that the prominence hierarchy, instead of having to be sort of a separate structure, is actually encoded by decomposing person and animacy features into a number of privative features, so that elements that are higher on the hierarchy have a greater number of features, and elements that are lower in the hierarchy have a lower number of features, and that these features are in an implicational relationship. So features of, for instance, first-person features imply the features that are found in kind of positions lower on the hierarchy. But whereas minimalist analyses of these usually encode the implicational relationships between these features in feature geometry, so sort of this separate structure, we're encoding it in a set of templates where each template calls, where the templates exist in a kind of implicational relationship. And so this is given here. And so you have these different person features, so entity, which is common to all arguments, animate, which is found on all animate arguments, proximate, which is only found on kind of third-person proximate and things higher than that on the hierarchy, and so on. And so notice that each of these ones calls the next template here. So the kind of, if an argument is a participant, it also has the local feature and also has a proximate feature and also has the animate feature and so on. And also notice that we have the inclusive template, which calls both the speaker and the hearer features. This encodes the fact that first-person inclusive in Algonquian languages is treated as having both first-person and second-person features. So the first-person features play in more with the morphemes that realize the agar node, whereas the hearer feature is more relevant to the voice heads and the person proclitics. We also have templates for plural and singular, and certain other ones here which play into certain other VIs. The next set of templates has to do with argument structure. And so these are the ones found here. So we have for instance, for the transitive verbs, we have the VTA template, and for intransitive verbs, we have the VAI template. The names of these are taken from traditional Algonquianist literature. So VTA means it's a verb that is transitive with an animate object, whereas VAI means it's a verb that is intransitive with an animate subject. There's two other ones here involving inanimate arguments, which we're not going to discuss. And so the VTA template says that in the semantic structure, you have two arguments. You have an agent-like argument and a patient-like argument. And it says that if you have an object in the F structure, it's going to be animate. The VAI one calls one semantic argument and says that if the subject is going to be animate. And then the mapping between the F structure grammatical functions and the S structure arguments is accomplished by these direct and inverse and reflexive templates. So direct basically says that the subject maps to the agent and the object maps to the patient, whereas inverse is the opposite situation, where the subject maps to the patient and the object maps to the agent. And finally, the reflexive one says that nothing maps to the second argument. So semantically, you have an agent and a patient, but you don't have any syntactic argument that maps to the patient. And instead that the referential index of the patient is the same as the referential index of the subject. So basically the typical LFG analysis of reflexive antecedence relations. This captures the fact that a reflexive form in Ojibwe is treated semantically as having two arguments, but syntactically is treated as an intransitive verb. And so for this, we kind of adopt the mapping theory of Finley, but we kind of have to adjust it in a few ways in order to account for the properties of Ojibwe, which are a little bit different from the argument mapping found in more familiar languages. And now we'll move on to the constraints that ensure the prominence constraints on F structures. So remember that we are assuming that what we call the grammatical functions as prominence analysis, so that generally speaking, the higher ranking argument is going to be treated as a subject and the lower ranking argument is going to be treated as the object. So now that we have our templates encoding the decomposed person and animacy features, we can encode this in terms of a subsumption relation. So basically this, in most cases, the person features of the object are going to subsume the person features of the subject. But this is different when both arguments are first person or second person. So in clauses that are like I see you or you see me, those are treated as direct regardless of the prominence, regardless of the fact that second person is often treated as outranking first person in the prominence hierarchy. And this is a very common analysis in Algonquian work, because of the way that the voice heads that are used in these particular cases seem to mark object agreement with the first person or the second person argument in these particular cases. And so we have this constraint here in 14 that says in the independent order, so in matrix declarative clauses, if it's a transitive clause with a subject or an object, either the object person features are going to subsume the subject person features. So either the subject is going to outrank the object, or you're going to have or both arguments are participants. So both arguments are either first or second person, in which case this constraint doesn't hold. And so basically this rules out any F structure in which the subject outranks the object, except when both arguments are participants, which is what we want here. And in the conjunct order, in kind of either non-declarative matrix clauses or in embedded clauses, the constraint is somewhat different, but we won't get to that. Basically, it allows for direct marking if either of the arguments is first or second person, not so much when both of them are first or second person, but we won't get to that here. We'll just move on to the vocabulary items themselves. And I won't go over each one individually, but I'll just go over, kind of briefly talk about the different categories and the items that fall into them. And so we talk about vocabulary items for four categories that are involved in an agreement. So there's the subject and object clitics, there's the voice head, which encodes direct and inverse, and there's the agreement head, which agrees with one or sometimes both of the core arguments. And so these subject proclitics, we call them subject proclitics because they usually mark features of the person of the subject. Although when you have a second person object, it's going to mark features of that instead. This is accomplished with these VIs here. And so here you see the V mapping, whose input is a pair, right? So there's the first argument of the pair is a list of C structure categories, which in most cases is just going to be a single category. And the second argument is a function, this phi function, which maps an F description to an actual F structure. So here basically this G is inserted whenever one of the arguments is the hearer. So basically a second person. Ni is inserted whenever one of the arguments is a participant and when there's not a hearer. So basically when you have a first person argument and no second person argument present. And then O is inserted for intransitive clauses, so it's absent in intransitive clauses. And when one of the arguments is third person, when you don't have a first or second person argument present. And so this allows for DM style competition between these different elements. Only one of these elements is going to be inserted, and the one that's inserted is going to be the one that's the best fit for the the features of that particular C structure node. Similarly, the object analytics encode features of the object, but notice that the only VIs that we have here mark elements of the third-person ones. So when you have a third-person plural object, you get ag. When you have a third-person obviative object, you get an. But when you have an object that's not third-person plural or obviative, you don't have a CLO head. More interesting is the agar heads here. And so for the agar node, you have a bunch of different VIs that all compete for insertion. So recall that the agar node contains features of both the subject and the object. But most of these VIs only kind of index features of one of them. So some of them are constrained for features of, like, whether there's certain features of the other one. But basically, most of them only actually index features of one or the other. And so non is inserted when you have, for instance, a first-person plural subject, unless you have a first-person plural subject and no object, or a first-person plural subject and the object is, for instance, another local participant, so another like a second-person element. And the imin and im elements are actually specified for, they can mark features of both the subject or the object, which is accomplished by this -r thing here. So basically, if either of the two -r roles, so subject and object, are speaker in plural, you get imin. And if either of them are participant in plural but not speaker, then you get im, and so on. And then finally, the voice heads mark both whether the clause is direct or inverse, which is determined by the constraint that we showed earlier, and also object agreement, so features of the object here. And then you also have this one which marks reflexive morphology, which we saw earlier. So these are all the agreement morphemes, the VIs for the agreement morphemes. The examples that we have also have a few other morphemes. So for instance, there's a past tense morpheme, there's a root meaning C. One of the structures in the appendix has a root meaning arrive. And then you have the little v verb class morphemes marking, like, whether it's a transitive animate or an animate intransitive verb. And then finally, in one of the examples in the appendix, we have an example using the verb to eat, which is actually the first example that we have of spanning here. So wisini is marked, it specifies features of both the root, so the pred feature is found on the root, and the verb class features found on little v. So that's shown in the last example here. And for the most part, I will leave the I'll leave it to you to look at the examples themselves and work your way through them. But I'll just highlight a few things here. So first of all, in this first example, we have an example of what we call Pac-Man spanning. So remember that we have various VIs for the agar node, but none of them are specified for when both arguments are singular. So rather than having, in that case, having the agar node not spell out, we assume that it's spanned by this kind of voice head, the direct third-person object agreement node, just because otherwise, it would either not serve as an input to the v function, or it would have to map to nothing. So basically, this Pac-Man spanning, where something just kind of gobbles up the features of anything adjacent to it, allows us to kind of serve as this sort of elsewhere case here. And these other examples kind of just exemplify the rest of the agreement system that we have here. And I'll just draw your attention to this last one here, 8, where again we have this element here which indexes features of both the root node and the little v node, so wisini. So thank you very much for your attention, and we would very much appreciate any feedback that you have on our theory. Thank you very much. Have a nice day.